Hey, hi everyone. Welcome to the series on quantum computing. So, for the last couple of months, I've been exploring a few of the quantum computing use cases. What are the advantages that we can get from it? And uh, for doing this, I require to go through all the resources that are present on the internet. And the agenda of this series is to cover up the lack of resources that I faced during my journey. Why the lack of resource, though, right? That's the basic question that comes to anyone's mind. So let's say somebody wants to learn NLP, okay, natural language processing. Now, because AI is a field which is more than established now, I mean, certainly not 100% of the world's organizations are using AI, but the leaders are definitely using. So when you want to learn a technology which has been established, as well as there are people who have already worked in this domain thoroughly, and when I say worked, I mean that straight away from professionals to people who are just entering into colleges, uh, their undergrads. People are already working in natural language processing, publishing papers and stuff. And it has already been commercialized. You are utilizing AI in your web applications, your mobile applications. So when you want to learn something that is so established right now, and you go out on the internet, you'll find various resources, public resources, free resources on YouTube, blogs written on it, and when I say that you're learning something for the sake of putting it into production, not only understanding the theoretical part, but understanding what you need to do in order to put it in an environment that is easy deployable. You can easily monitor the results, and you can easily redeploy your models as the uh, demand of the kind of product that you're utilizing it in. So when you compare it with something that is rather new or something that's rather more complicated in terms of the amount of theoretical knowledge that you need to know before you can utilize it to solve some sort of real business case problem. Is that there is not there are not a lot of resources out there which you can utilize. So if you search for, let's say, quantum computing, Cube is something that we'll cover later in the series, but let's say you're trying to search on Google, you see that most of the documents that you get are generally either research papers or either you're getting YouTube channels of the uh, official documentation itself, and it's really difficult to able to connect all the dots. So whenever you want to learn something, you have to like go through all the resources that are available, and then you have to sketch out, okay, how is this thing linking to this thing? Are there any companies that are solving this problem out there already? Have they utilized some sort of quantum computing resources, cloud resources? How do I access a quantum computing resource? Because obviously, you cannot, the quantum computer is not something that you can buy and keep it in your home. So all these questions came up, and I was trying to uh, solve all these questions by reading and consulting tons of resources. A lot of people I consulted. So the agenda of the series would be to cover all the resources that are there online, and what I'll try to do is cover them in a way that you don't need to join all these dots. So this these sessions that we will be adding to the series, basically we'll be starting from the scratch theoretical aspect. We'll be going through all the cloud providers, the approaches that they're taking in quantum computing, and how to sum up all these resources into production. Now, when I say that uh, I searched how companies are trying to put these solutions into production, we need to separate what's the media hype versus what's the reality. A big challenge to AI was hardware resources, right? If you're looking at AI, the state of AI a decade back, right? If you're talking about 2012, 2016, one of the major problems that we were facing was okay, large models cannot be trained so easily because it's very intensive. Something similar is happening to the quantum domain right now. A lot of companies are creating quantum computers that are exceeding the physical limitations of the last decade, the last year, I might add. But we need to separate what is the media hype regarding to quantum computers and what can be achievable, what is achievable in the next 5 to 6 years and maybe down the lane, the next decade. So we will keep that in mind when we are exploring the use cases. So we'll be starting with the basic algebra and basic mathematical requirements. Most probably, I'll be talking about the Qiskit approach, the Qiskit and IBM approach of quantum computing, and then we'll be talking about D-Wave, the collaborations that these companies have done with the big tech organizations. So another thing that you should keep in mind is that for any field that is mathematically intensive, there is a basic fine line between research and between getting something out of the research in terms of business value. So if you're working as a developer, it's not that some company will just give you time to experiment for the next decade. Whereas if you're working in a research organization, completely research organization, people will back you up. And you say that I need 5 to 6 years down the lane to come up with something that will be groundbreaking. That's again a balance we need to strike because this series will be more developer friendly. And because anyways, there are tons of resources, tons of books and research papers for the research and academia folks. And hope you enjoy the series and you get to learn more in the future.